Hi there, my name is CCC Super, and welcome to my channel. Here we focus on everything coding related, as well as everything encompassing AI.
And today I'm going over the changes that I've made for the Ray Pathfinder that I programmed during the stream of a few days ago. So as you can see, I have this ray swooping across the area, logging different positions every time it transitions from a point. So with this being said, if at any point you do want to copy the code over and try it for yourself, feel free to pause the video and type it out as I explain through the video what each portion of the code does. Alright, so we're going to start by looking at ray pathfinding. I recommend that you watch the previous videos so that you can see what all the variables are that I'm going to be making use of. Like for example, ray angle here is being specified and calculated outside of ray pathfinding. So this is purely my focus, just this one here. So first, we need to work out the direction of the ray that we're going to be projecting, which is this ray angle, and we're starting it from the down position, meaning going from positive y to negative y. So then we're passing this through path ray, which is a raycast hit 2D, to calculate a ray in the direction that we have calculated it, and to a maximum of ray max. And we're also looking for anything that falls under ground layer. So after we've calculated the path ray, we are specifying rounded hit points because we are rounding the ray to an int. And for now we're just setting it to 0, and then we take if the ray is not null, then rounded hit x and rounded hit y both get the position of path ray rounded down to the first point of the decimal. Next part, we're checking to make sure if the ray isn't coming from a void position. So first we need to check if the ground and the wall are both set to false and the ray position 1 is set to 0, and also the collider is empty, as in the ray is currently not touching anything, then ray position is set to the rounded hit point, and the ray path has ray position 1 added, and we draw a line between ray position and the direction of the ray, and we color it yellow just so we can see it. Alright, now we are checking specifically if there is something detected by the ray. So if there is something detected by the ray, then ray position 2 gets set to rounded hit point. Now we are comparing ray position 1 to ray position 2, and if they don't match, then we're checking if it's ground, if it is ground, if it is wall, and if ray position does not equal vector 2. And once we've checked that, we are checking to see with mathf approximately if ray1 and ray2 x, as well as ray1 and ray2 y, that is ray position 1 and ray position 2, to see if they are roughly the same, and if they are, then if x is true, then we set the wall to true, and if y is true, we set the ground to true. Otherwise, if this is not true, then we're checking if the wall is true and ray position 1 and ray position 2 x do not match, or if ground is true and ray position y and ray position 2 don't match, which is this math approximately, then ray path then we add to ray path. I'm reading the code as I'm saying this. And then we draw a debugger line in the direction of the ray. And then we also set ground to false and wall to false. And we do another check to see if ray position x and ray position 1 and ray position 2x are the same to set wall to true, and the same goes for ray position y and ray position 2 to be able to set ground to true. And then we pass ray position 2 to ray position 1. With this, we are checking to see if there is any changes between the ground and the wall. And then lastly, if the ray collider is null and ground and wall are both true, then we add position 1 into the ray path, and we draw our debugger line once again in the direction of the ray, and then we set ground and wall both to false, and ray position 1 and ray position 2 both to 0. Additionally, we also have here, if the path ray is not equal to null, meaning it did hit something, then we check the distance of the object's position to the pathway point, and we draw a green line in between those 2 points. And then otherwise, we draw a blue line in the direction of the ray. Alright, that'll do it for today. Thanks so much for watching. Also, be sure to check me on ECC_super on Twitch to catch me live whenever I go live. I do most of my coding there, and that's also where I'll be continuing the next part of this project, which is what we do with these points that the ray has captured. I made a few changes to the code of last stream. You can check the changes I've made in a YouTube video that I made. It's on my YouTube channel, ECC Super, and it's part 4 where I made the changes. Now, off camera there were a few more changes that I went and made, and amongst those changes is this one, PBN, which stands for Physics-Based Navigation. So this is ultimately what I was actually aiming for. I already started moving a few things around, but I'll explain that real quick for those who are watching this afterwards. So I went and added this so that we could check for ground layer, and then I went and copied all of these over. So these are all of the variables that we're going to be using. I moved closer to here, as well as added everything that it requires to be able to do its stuff. So PBN is going to be attached to the object that is trying to perform this. Additionally, I also moved this check here, which is now rate check, and it gets fed target, and it's a bool, which means it returns false or true. So basically, if this is less than 360, it returns false, otherwise it returns true. So I made that. And then here, this is the array pathfinder. I'm not going to go over the script again. You can check my YouTube video for that. Now that that's sorted, I'm not done moving everything over yet. I had a major headache earlier, so I kind of just did things, but I'm feeling better now, so let's grab this. So this is move away, void, and I basically want to feed the exact same things into it. Like that. Set it to public. Public void. There we go. And then remove it from there and add it in here. Right, so we have move away, we have move closer, we have ray check, and we have ray pathfinding. So all the basic stuff that we need is in here. And then I need to obviously fix something here. This is pbn.move away, and then I need to add in all of these. Alright. Also, additional changes. If I scroll up here, I added this and this, which is the PBN script, and then I'm just simply calling the functions from PBN. This one's here somewhere. Can move, I actually want to move as well. So where is can move being called? It's being called in quite a few places. Right, should be easy enough. So grab that, come over here. Set it to public. Oh, right, the offsets and the ray detections. There's a few things I need to move over. Brain. Let's fix this side first. So there's a few things that's going to bug out here. So here is dot pb oops, no, it's pbn dot can move, and same here, pbn dot can move. The offsets I can copy over. Can actually get rid of this. Because I'm already calling those somewhere else, so here, I'd like to get rid of these. Doesn't look like it breaks anything, so come over here. Oh, well, that's awkward. Detection ray and detection rays. Sight ray, and then detection ray. Anything else? These need to go over. And target layer, which will go over here. Public layer mask. Target layer, which should sort this. Yes. Alright. Start I can collapse. Awake I can collapse. Here. So what I want to add in here is ray check. But in order to do ray check, I need can move. Okay, so this one specifically if we're trying to get closer to the enemy, then so that means this is for our melee enemies, not for our ranged enemies. So for our melee enemies, if can move is equal to false, I actually want to then do .ray check, and in ray check I am supposed to pass target. Right. So this is interesting. Let's see this in action. That is the wrong thing that I just clicked on. So the enemy, I need to add PBN to it. Ground layer is ground, target layer is player, race speed is 50, max race 30. Offsets is ray 1 was left, ray 2 was right, so this one's offset is minus 0.5. This one's offset is 0.5. And these is 0.5 negative. And 0.5 again, and then this is negative 0.5 and negative 0.5. If I'm not mistaken, that's what they were, so this is being done regardless of whether this is true or false, so let's see anything else I need to do. I'd like to keep an eye on that. So let's hit play. Oh, it's because it's set as ranged. Sorry, my bad, my bad. Set it to melee. Hit play again. Oh. It is spicy. Oh, it just did that. Oh, that's interesting. Alright, well, at least I know the logic works. That is perfect. Right. So both scripts still work. That is good. So that means I did not destroy everything. But we are now running into a problem where it's continuously running this, and I'm not doing anything with that information. So let's collapse this one. Let's collapse this one. Rate check's a bull. Now, I am supposed to pass certain things here. Because here it's just running rate check, which is fine, but what I actually want to do is if why did it work? Wait, what? Why did it work? Should I just maybe do a while loop? Wait, I am so confused right now. Why did that just work? So and then it performs a function. Wait, I think I know how I want to do this. So if this is true, because this is doing this at the same time, then and this is where we now start the processing, because as soon as what we have confirmed that is true, we can perform the next phase, which is where I am going to start going over my notes and stuff to explain to you what I'm planning next. So public void, so we've done the ray check, we've done the ray pathfinding, although that is incorrect. This is the ray, not pathfinding, but ray edge finding, and now we're doing the actual pathfinding. So with the pathfinding, we need to run a few checks. So let me grab my notepad. Bring this over. Sorry about that. I just quickly need to do something. Alright, that covers that. Bring that to the front again. Right, notepad. Where's my notepad? There it is. Alright. So, this is where things are going to start getting a bit tricky, because now we now have the points of where everything starts and where everything stops. However, the problem is that that's just points. We now need to figure out, first of all, the target relative to the entity. So let's say the target relative to the unit. So we are going to be comparing y. So if the unit dot y is less than the target dot y, then we know we are specifically looking for y1 lower than y2. So let's do y position and y position. So we do that. So this is y.1 and then y.2, or y position 1 and y position 2. This being the first position that it logs, and then this being the next position. In fact, let's do this. So this is y.n, which means all of the positions are being compared to this. If all of them are greater than this, we then need to check if point n is greater than max height. So this is also another piece of math. This song is frustrating me. Yeah. So this is just going to be another piece of math where we're going to do ypn minus yp1, and then we're checking if it matches max height. Otherwise, or actually, no, let's do this. Is lower or equal to max height? If yes, then from its position we need to cast a ray at 35 to 45 degrees. What would be the correct way of doing this? Let's just do that for degrees. I know that's inch or foot, whatever measurement that is, but whatever. For now, that is degrees. So both left and right. And then once it's casted those rays, we are checking to see if ground. Alright, and then if it does hit ground, we check if y point ground is equal to y point 1, is set equal to, yeah, so if ground is equal to y point 1, then we know we can jump from that position. And so this is the first logic. The second logic is if it's less than. So I can literally just copy this and use this. Oh, don't tell me inserts on. There you go. So then we check that. We are not checking for max height or anything. I kind of wanted to be able to just jump. So I think I'll still run this just to see if it does hit ground. And I don't think I'm doing this check. So if it does hit ground, then it does move forward. So because it doesn't have to jump, it just needs to apply force in that direction and it should be good. Next one is if we want to jump along an equal plane. So once again, this is equal. We're actually going to be using something else other than equal because of how decimal works in coding. It's very buggy. But we're going to be using unit y is equal to target y. This equals, we're looking for all y positions equal to y position 1. And then we are looking for, then we take y position n, and what we're checking is not max height, but max distance. Because this is if we're jumping across a gap. So we don't cast a ray at this direction, we just cast a ray both left and right to make sure that we can actually cover that distance. Although this isn't really necessary because we're already checking this. So this yeah, I'll remove this check. This check's not necessary. So then we do, yeah, ypn is equal to yp1, then we do jump again. So this one's a little bit more complicated other than just jump. We're first going to do a move to, and then ypn, and then when we arrive there we jump in, so this is not ypn, this is ypg. We move to ypg and then we jump in ypn direction. Right, So that right there, that is the logic. So let's get this coded over. Well, let's get this done over into coding. So first of all, we need to do a for loop with raypath. So first I want to do for let's say no, this would be vector2. So vector2 this won't be that. This would be, oh, no wonder it's that hot. My fans are off. So this would be path this will be valid y is equal to new vector2. So for int I equal to 0, I is less than raypath dot count I plus plus. Right. So first we check if, wait, let's first do the math. So we're looking for positive, equal, and negative. Ah, screw it. I'm just gonna do the ifs. If target, oh right, I'm not capturing target, am I? This gets game object target. So if position y is greater than transform dot position dot y, and I need to do else if, why'd you do that? Else if, then I need to check the opposite. And then else if again, math f dot approximately, and then it is these two. Also, I need to switch this. And then swap this out for a comma. Right. Now to start with the main logic. So So if so let's do another vector 2. Let's do ypn is equal to arraypath.I. So I'd like to do another thing here real quick. Yeah, that looks correct. So if, right, then here I wanted to do an if I does not equal 0. Wait, no, it's gonna skip it anyways. No, it won't. Because right now it is checking I0. Yes. Else valid y I made a mistake here. This is supposed to be a list. 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 Alright. Valid y dot add ypn. Right. Otherwise, if it is not the first, then no man, why am I adding it? I can just like not have anything there, so it skips over the first one. Now I can test and vector 2 y point 1. Well, y.0, since that's how we're actually calculating it. Dot this gets arraypath 0. Specifically arraypath 0. So now let me just change my logic here so that I don't get confused. So if y n is greater than yp0, alright,
so okay, so we now have this. I now need to check if this is less or equal to max height. So let's add a variable here. Private float max height is equal to, let's do 4f. Just gotta double check that. So this is 2, that's 3, that's 4. It's going to calculate it using that position there, but it's in any ways going to have enough force to be able to jump that, regardless of what that position is. My only concern is if it's going 45 to there and then attempts to jump. Do I have any? No, I don't. Alright, let's work this out real quick. And I already made a mistake. Enemy needs to be set to range just so that it doesn't bother me whilst I quickly do my calculations. Right. So if I'm here, so this would be 45. Yeah, this would be 45. Oh, I can make that from 45. And I'm measuring from this position here. So roughly there is 45. And bam. So as long as what I have constant force. Yeah. Alright, doing shift and that doesn't work, but that works. Okay, what is the minimum now? So if this is 45, 35, roughly? Okay, so I think is this would be roughly 35. I think I'm gonna use 35, and then I'm just going to use the same jumping variables that I'm using with player character. I do want to make this variable that the moment I release space, that it stops doing this. Because I only want it to jump high the longer I hold in space. I can deal with that another time. Alright, so max height of 4, and this is 4, well this is 3, that's 4, so let's change max height to 3. I feel 3 would be a better number. Head back down here, we need to check max height, so wait, let's first do float height is equal to ypn.y minus ypo.1. That is how that works, right? Because one's higher than the other. Float height equals ypn.y minus yp0. Let me just quickly whip up the calculator, just because my brain's not functioning right now. Let's say ypn y is 4 and that one is 2. Yes. Okay, cool. So then we need to do another if statement. so if height is less or equal to max height, right? So that is this part sorted. I wonder if I can highlight it. There you go. Let me make it bold. That. And yeah, I think that's about all features I can add to it. Right, so next part we need to, once we've determined that, I would, instead of doing that, I would like to do valid y dot add ypm. Right. Let's copy this logic over real quick. So here we said we were going to do things a little bit differently. So we're first going to check. So this one, yeah, we're actually looking for y that is equal to itself, because we're looking for a y that is closer to the target position. So target position is lower. So let me grab paint. That. All right. Right. So if y is lower, so we're testing from this to here, and I'm just going to do that. Make this one. Yeah. We are then going to project rays this one's blue. Yeah, you see it would not have been able to get that one. So we are actually just looking for rays that are on the same level. So instead of less, we're looking for same. So that same would be same to this one, which was the first ray. And then we're checking these rays to see if they match this ray. If they match this ray, we are checking to see if this ray, I'm gonna make this one red and set it back to an arrow. If this ray is closer than well, let's put that aside. We're checking which one of these two is closer, which obviously is this one. Right. So with that being said, I'm bringing this back over here, pulling this logic back up again. I'm just going to, in my notepad, just going in my notepad to change this to equal because it needs to be on the same level. So we are actually going to change this to an approximately then. So this is not the right way then. So we are checking then for bracket math f dot approximately. And we know we're going to use it again, so just copy and paste this. Alright. Then we're not checking height anymore. So all we're doing is we're checking those that are approximately the same y, and those ones we are adding into valid y. And then the same with this. I don't have to go as complicated here. Right. So the reason why I'm doing this section by section is just to make it easier for myself to actually visualize and see what it is that I'm trying to do. We have now effectively done the following. Right, max distance still needs to be checked. So I'm not done with this one, but I am done with this one. So here, I was an idiot by doing what I was doing. I'm going to copy that, paste it down here, but we're not doing height, we're doing distance and distance, and we're not doing max height, we're doing max distance. So serialized field, private float, max distance is set equal to, I don't have max distance anywhere else, right? No, I don't. Okay, this is set equal to 4f. For now, I can obviously tweak that. And here, set this to max distance. I'm gonna move this one to the other side. Right, so now all of our valid Y positions should now be saved. Now I need to apply the rest of the logic, so what I need to do is if valid Y dot count is greater than 0, else we're going to add a debugger here. Then I need to do a for loop for, close that up. Int I is equal to 0. I is less than valid y dot count I plus plus. Right. Do a quick if statement. If y is less than valid y I, so let's do vector 2 ypn is equal to this, and this I can replace with ypn, no, like ypn else target dot transform the position dot y. Oh, wait, this is supposed to be a math thing. This is supposed to be this. No, actually no, it's supposed to be this, because we are first performing the logic for jumping. Right, so this one's actually going to be very, very easy. We first need to calculate directions, so if I go to can move, it receives check the player, so we need to pass through true for this one. So wait, we're not trying to run can move. That's the wrong one. I was staring at that now. Move closer. I somehow need to pass these through. Hmm. That feels like cheating. Right. The problem that this code could potentially be facing is what if it overshoots the platform the player's standing on? But I also feel like there's a poetry to that. Because if it just suddenly decides to jump forward and misses the player, or misses the platform and it falls even further down, and it lands on something else, it could always try and find its way back to the player. Yeah, I like that. I like that. So this is not correct, but it's what I'm going with right now. Oh no, this is supposed to be this. But I'm not going to be doing this. That is wrong. Alright. First, this logic. So what we're doing is YPN. We want to cast a ray from that position. So how does that work again? I'm just going to copy and paste this. I'm going to copy and paste both of these. Right. So back to the actual pathfinding. So we're facing downwards. So this is supposed to be 45 from facing down. Wait, I know. Right, so direction left, direction right, direction left down, direction right down. Right, so this one is just vector 2 dot left. This one is vector 2 dot right, and then goes clockwise, right? Which means this one's this. There should be a down. Direction left, and we are using max height. Well, actually, no, we're not using max height because all we actually want to do is detect the walls. So that'll be 1. Left, right, left, down, right down, just left down, right down, and we're using max height. Max height. So then we do if path right left dot collider equals null. Then we check if except this one must be this one, because for some reason I misnamed this one. There you go. Oh! So many if statements. Alright, so if path ray left dot collider is equal to null, if path ray right. No. Why am I using this one? does not equal collider. Right. So then I want to set this up here. Should I make this a list? Maybe. I keep doing this to myself, I don't know why. Okay. Just get rid of these because these are annoying me. Okay, so once I have those, then I'll run this one. So here, so then potential targets dot add path ray dot point. Alright, I just need to copy this. To here and here. Oh, my brain's busy burning out. Okay. Let me see what I'm doing here. I need to remember that this is all in a for loop, which means I'm gonna have one last for loop that checks potential targets. Oh, why is my brain struggling? Why is my brain struggling? So I'm gonna do the next for loop outside of this one. Well, no, not outside, inside of these brackets. So it's outside of the for loop, but it's inside the if statement. Right. So this one's gonna have something similar. So if potential targets dot count is greater than 0, then we do some stuff. Right. Sure. I think I'm going to borrow, because Sprite's being passed through it, I think I'm going to borrow a script from here to add it into here to check the direction in what the player is looking, so that I don't have to do whatever the fuck this is to determine which direction it needs to go, in which case I just test the distance between everything, and the closest one, if it's within the range, then it jumps. But also, because I'm busy comparing x's to one another, that sounds wrong. Because I'm busy comparing x to x, it's going to, in any ways, zone down to the one that's the smallest. So I don't have to do potential target for this one. I'm literally just doing potential target for brain, come on, brain, come on. I am literally only doing potential target for anything that is above a certain Y level. So with that being said, let's quickly go up to move closer, and this is what I'm talking about. So we need to check in which direction Sprite is flipped. If Sprite dot flip x, yeah, I should be able to just search that, and then we do else. Right, so if it's flip x, then yeah, so if it's true, then we move left. If it's false, we move right. And I need to create a script that handles this. So this one, we're jumping left. This one, we're jumping right, just so I can keep track of that. for potential targets. I know I'm doing this wrong already. Int I is equal to 0. I is less than 0. What am I doing? It's less than potential targets dot count. I plus plus. Apparently there's an error somewhere here. There you go. Okay. Back here. Potential targets dot count is greater than 0. For int I equals 0, I is is greater than potential target dot count I plus plus. Brain, function with me. Okay, I need to turn the music down for myself. The music should still be the same for you guys, but I need to turn it down for myself. I can't believe how tired I am. Okay. It's this damn heat. Right, so once I've projected it in that direction, I've gotten a position. That position gets stored into potential targets. Now I need to measure those targets, the X value versus the X value. So what I'm doing is I am taking distance. Wait, so let's do this. If temp target is equal to null, then temp targets is equal to potential targets I. Else if so first I need to do float distance 1, well, distance temp and float distance plot potential is equal to, let me just do it here as well so it stops complaining about that. So if this is equal to vector2 dot distance temp target comma target dot transform dot position, this one is vector2 dot distance temp target, not temp target but potential targets I and target dot transform dot position So if distance temp is less than, no, is greater than distance path, then temp target is set equal to potential target I. Alright, and then at the end here, if temp target does not equal null, then we do move closer, and instead of feeding a target, we're feeding it temp target, which will throw out an error. How can I do this? Right, so this has no game object attached to it. Alright, that's bound to cause some errors. That means I can get rid of this. That's the first thing that I can change. The next thing I need to change is here somewhere, where it's fed target.transform.position. There you go. Then I have some errors that would have displayed here. Just one error at least. There you go. And then I can go back here. No valid Y positions logged. And then it's this one's move closer to and vector 2 is equal to a new list vector 2, and then let's do private vector 2 yp right. fix. Dot add. Y at the end. Yeah. It should be 1-to-1 with this, so that should be correct. Alright, and then I actually want to rename this to I want to rename this to target. Right. Now I want to add an update. So public void update. So first we check if temp target does not equal null. Then we check if this dot transform dot position dot x. So we want to do math f dot approximate temp target dot x then I need to do something similar to this. So copy okay, wait, I think I'm making a mistake here. I don't want to use update here. What I'd much rather want to use is in this we want to add all of these. I think here is already a mistake. So I don't want to actually call move closer here because this is the incorrect place to call it. So okay. Okay, so I think I'm gonna end it here. My brain is literally soup right now. I'm trying to think. It's been a long day. I'm very tired, but I did manage to do quite a bit. I think let me just quickly fly over what it was that I did, just real quick again. So this is the physics-based navigation. So I'm just gonna put it here. Physics-based navigation. So this uses physics and rays to be able to figure out what path it's supposed to take. Here we're just declaring a bunch of variables and different things. And we don't have start or update here because we're actually planning on having that run somewhere else. Here we're attempting to move to the temporary target, which I have yet to put in. I actually think I want to change this to arrived at temporary target. So let's do that. Arrived at temp target. Here we're doing the basic can we move. Here we're doing move away. Here we're doing move closer. We're performing the ray checking here, the ray edge finder here, and then the pathfinder here, which determines which path it is that we're ultimately going to be taking. So, yeah, that was complicated. I am fairly certain when I hit play with this, when I'm actually done programming everything in place, it should work. And that's it. Thank you so much for watching. If you have any feedback, please leave them in the comment section. Also, I am open for suggestions for future videos. So, I'll see you guys next time. Bye-bye.